Alright, testing mic 1, 2. Testing mic 1, 2. Testing mic 1, 2, 3, 4. So testing mic 1, 2, 1, 2, 3, 4. Alright, so Kon-Kazu everyone. This is your electro student Vtuber, Natsuki Kazuya. So tonight we're going to actually start learning how to use one of the most common modules. I'm going to learn how to actually use this module, the FM module. So the FM module in Arduino is something that that's going to be the heart of the radio. Okay, before we start, sorry for interrupting. Is the audio actually okay? Is it loud and clear? I hope it's loud and clear, because if it's not, then maybe the BGM is actually surrounding the mic right now. So I hope so. If there's any audio problems, of course, as usual, let me know. So okay, what I'm gonna do tonight is to actually learn how to use the FM module. Okay, you guys can't see the chat, but I can actually see the chat from my monitor right now, so no worries about that. You know what, I think I'll just turn this off. There. And yeah, I can't see the chat box either, but I can see because I have another monitor with me right now, so I can literally see the OBS app. So I can see you guys, so don't worry about it. So okay, first of all, what I'm going to learn tonight is the FM module. So FM module is used to produce a frequency and convert it into a signal. Okay, I'm basically making stuff up. That's not actually correct. Okay, it's basically the module for an FM radio, like the ones you see in cars. Inside the cars, your radio and maybe in your phone, in your apps, you would usually see that there's the FM radio. So this is basically the same concept, but you have to program the board yourself with an Arduino. So first of all, I think we'll start to show what it is, as you've probably seen in the thumbnail. So here you go. So this is the, oh dear, it's a bit blurry, sorry about that. Sorry if this is a bit blurry, but I think you can see it clearly right now. So this is the TEA 5767. So I think we are I'm not actually going to be teaching you guys, but I'm going to be the one learning. So we can have some discussions on how we can actually learn how to use this module. So as you probably see in my thumbnail, in my screen right now, the bottom part, oops, I'll just put it here then. The bottom part here is my Arduino. So I'm basically going to crash my laptop again. I hope it doesn't crash this time, like what happened last week. Last week was a complete disaster with the Premiere Pro. I hope the ones that I am running right now are not actually that bad, because I'm actually going to run Chrome in the background just to search for codes and all that. So okay, so here's the FM module. I hope it's not too blurry for you guys. So, and here is the antenna. So this is going to be the one that's going to send the signal to the antenna, to the main tower, I guess. So the main tower is going to be the one sending the data back to this thing, and it will produce an output. So okay, my academy's tables are so damn small that I am literally going to squeeze my freaking shoulders and literally enjoy this tight squeeze. Okay, can we actually go closer? I don't know if you guys can actually see. So hold on. So first of all, I think from what I've read about this FM module, is this thing has 2 ports, one for the speaker and one for the antenna. Oh yeah, and also this is I think this is a cap. I'm not actually sure if this is actually a capacitor. This is the heart of this PCB, because this is the chip, the TA5767 chip. Yeah, of course it's according to what I've read. And of course here are all the bunch of resistors. I think they're resistors or capacitors. So yeah. But the one, and the chip is going to be the one that is going to receive all of the data and produce an output. So go back down here. This is the audio output. So the audio output, and here's the antenna. I think I showed that twice already. Oh my goodness. So I think we'll just put this antenna right here into where it belongs. So we shove that in here. There we go. So wait, oh yeah, also we have the pins. Oh wait, I think, okay, I showed you the pins already. 5 volts from the left. I need to do something about this. So okay, the pins here, this is 5 volts, this is SDA, this is SLC, and this is the ground pin. So the 5 volt and the ground pin, this is where we're going to connect to our power supply. So that's what we're going to use. So okay, I think that's what I'm going to learn. But if you guys would actually know, how would I actually put this, how would I actually test this? So like I said, the Arduino that you see that you see at the bottom, that's going to be what we're going to use. So this is the Arduino Uno board. So we put this down. So this is the board that we're going to use, and to be honest, it's actually a bit too big for the site for this module, because you don't necessarily need to use this board, to be honest. I mean, it's not really necessary, because you just need to simply get an Arduino Nano. So hold on. So okay, here is what you're supposed to buy actually. Here is the Arduino Nano. So look how it compares to, I'll put this here for a while. I'll just put it here maybe. Yeah, we'll put it down here. So this is the Arduino Nano. Man, how am I supposed to position this? Here's the Arduino Nano, and here is the Arduino Uno. So to make it more compact, just use this Arduino Nano. But and to be honest, I should be using it too. But when I bought this thing, I bought this thing from Shopee. If any of you Malaysians or Southeast Asian countries actually know about Shopee, this thing cost me about 27 bucks. So 27 bucks you can get, it's pretty cheap. I mean 27 ringgit. But then again, that 27 ringgit has been wasted because some idiot courier guy decided to throw my damn parcel onto my house. I will never forgive you, that parcel guy. So basically, when I want to plug this thing, so what happened is that something must have broke onto the inside the PCB. So if we open this from the polystyrene, got ourselves this. So this is the pins that are going to be used. and this is going to be plugged into maybe a soldering board if you prefer to make things permanent. And last, a permanent mark on your, and convert this into a device basically. So okay, so converting this, so you plug this in directly onto the board, and then you connect it with some jumper wires so that you connect it to the other devices like this thing, and maybe like a battery or a potentiometer or other sensors that you can actually use. So okay, we'll put this back. This thing is absolute, it doesn't really work anymore, which is really sad. So I'm just going to use this board. So my recommendation, get this instead, and make sure you tell whoever you're actually buying it from to get a fragile sticker. And if you can, just tell the courier services to not throw the damn parcel. You should never ever do that, you know. I really hate that. So okay, enough about that, and we're going to start with these two components. So we're just going to do some simple interfacing. I actually have some speakers, but first of all, the speakers that I'm going to use is just a simple speaker. You can use any speaker that you like, maybe a bare bones version of a speaker, maybe even just the speaker component itself can also work. So hold on, let me get a speaker. Okay, sorry about that. My earphones got in the way. So okay, this is the FM module. So this is the speaker that you can use to plug it to your output. If you actually have like a 3.5mm headphone jack, plug this in, and you're good to go. You can get an output from this speaker alone. So okay, but we're not going to use that. We're just going to use some regular desktop speakers that I borrowed from my friend. But yeah, just keep in mind that there's going to be a bit of a background noise because I'm actually streaming from my academy. So I'm just going to learn how to use this component. So enough about the intro. I think we'll start combining these things together. So now I have my breadboard, and I have this. I have this thing, the Arduino Uno, and we have the FM module. So I think we can just put this directly onto the breadboard. So from my years of experience using a breadboard, I guess, when I'm still learning. So these are the so this is like the 5 dots here, but you also have a metal strip at the bottom, so it's going to be conducting. This is basically like a vertical conductor. So if you see in an electrical circuits, sorry, are my hands too veiny? So in a schematic diagram or in an electrical circuit, you would say that this is kind of like the metal strip is like a conductor, basically a vertical wire. So if you want to actually like put in components, you shouldn't put them like this. So if you see the pins right now, you should never ever put them like this. You will short the pins and you will potentially destroy the circuit. I think that's how it works. But yeah, you should never do that. You should always put these pins vertically. So we put this down here. So I think if I remember correctly, So okay. So if you see this pin, I don't think you'll be able to see it because it's not clear. Okay. So this pin right here, this is actually the 5 volts, and this is the ground. So you need to remember that. So okay. Now we got this. We need to plug it in to our Arduino. So yeah, for now we'll start focusing on the hardware first. I think we'll put this over here. Oh no, where should I actually plug it? Oh, okay. Yikes. I actually don't know where should I actually plug it in. Oh my goodness. Okay, so I think this is gonna be a bit of a pain. So hold on a minute. I think it's time I take off my mouse. So we put this out, push this out, take it off. So yeah, I'm using a mouse, but I think we don't need that. We don't need that for the time being. So there we go. Arduino lights up, and there's the on. So what we're going to do, I think we're supposed to have to make things like this. Test. Okay, I hope you guys can hear me loud and clear. So what you will need is an Arduino Uno T. So here's the circuit. The connections are pretty easy. See the above with the breadboard. Wait, there is supposed to be a specific port for the TEA5767 because there is an SCL. Yeah, so there's an wait, let's see, SDA pin right here below the 5 volts, and then the SLC. So that's what we're going to put. Alright, so now it's 9:18, so I think we need to find how can we actually interface this baby. So hold on a second. Yeah, but there's a lot of websites that you can actually use to put this Arduino components in to actually test the Arduino. So hold on. Prog, Syntonia, blah blah blah. Oh yeah, I think we need to get ourselves the pot, the potentiometer. Wait, before that, let's do things one by one. I don't know where the heck did I find. Where should I actually search? So, okay. Yeah, I'm trying to search for the website. Any website that we could use. Okay, so SDA data. So this is an I2C FM radio. So you can see the pinout, blah blah blah, circuit. Why do you have to put it to A4 and A5? That's a bit strange, actually. Hold on. Yeah, I don't think I understand this. So, hold on. What just happened? Okay, we put this back in. So I think that's a bit weird because I actually saw one of the articles about an FM radio that we should actually put this into somewhere about here. So these two pins, SLC and SDA. So Okay, SLC and SDA, SCL and SDA. Yeah, remember, you shouldn't use an Arduino Uno. Yeah, you don't have to use an Arduino Uno. Arduino Nano is enough. I don't want to buy. Why is Google searching articles about buying the damn thing? I don't want to buy it. So Arduino FM module. So okay, because interfacing. So I'm trying to learn how to actually interface this. So interfacing this is going to be the difficult part, actually. But I don't know why is it actually going to use analog in A4, A5. There's gotta be some specific ones here. Yeah, I think there is something wrong. Or we can just search the Arduino pins, Arduino Uno pins. Okay. So the full Arduino Uno guide, circuito.io. So okay, there we go, found it. So I think if you see this very carefully, the furthest pin is actually SCL, and the pin before it, we'll call this a female pin. So the female pin, the furthest one is SCL, and the one next to it is SDA. So SCL should be to hold on, sorry for the camera, should be to SLC, which is this one, the one on the, yeah. So this is SLC, this is SDA, SLC, SDA. I'm trying to put this into my memory and store it as long as I can, because I think I'll forget it so quickly. So this is SLC, and so the furthest is SLC, and the one next to it is SDA. So okay, I think that should be easy enough. Hold on. Wait, where's my mouse? Oh. Okay, I think we need to get ourselves a few jumpers, so please give me a second. Oh yeah, by the way, is my BGM actually doubled? Do you guys actually hear like 2 BGMs? Okay, wait. Let me change that. Hold on. There we go. So I switched off my monitor output, so I can't hear the BGM. I hope you guys can enjoy my BGM. So okay, hold on, let me get myself some jumpers. Okay, so I think I got all of my jumpers now. Ah, no, I got the wrong jumpers. Okay, so wait, rather than that, wait. So this is a female to male, as you can probably see. So this is a female to male. Hold on. So this is a female. This is the female area, and this is the male area. And this is okay. This is also the same thing. So yeah, as you can probably see. So okay, what we're going to do is I should have took male to male, so that we can actually we can just plug this into the breadboard, but I don't think we are actually going to use that now. So we're going to take this off. We took it off, and we're going to plug all of them directly into the Arduino. So we got this, plug this in, and I actually need to remember where should I actually put these things. So put this inside, we stuff them, come on, stuff it in, get in there, come on. Ugh. Ah, bloody hell, why is it so hard? Why can't it fit? Need to shove it in. Yeah, we need to shove it in. Oh my goodness. So if we're actually going to shove this in, this is so hard. Why is it so tight? Okay, come on, I think it can fit now. Alright, so hold on a second. How is it? How can it fit inside? Come on, just fit. Sorry for any background noise, everyone, because my friends are having a chat at the back. So, no. Oh no, I bent it. I actually bent it. Okay, we took it out. So I think we'll have to find another kind of. Okay, we'll put this here, and then we'll put this there. Let me get myself my jumper. So some jumpers. So we got that down, and now we shove the last one in. Hope it fits. Okay, it fits. So 5 volts to 5 volts. Hold on, I think. Okay, so ground to ground. So this is the. Sorry if it's a bit too dark. I hope you guys can see what I'm actually doing. So V in. This is a VN. Okay, so this is supposed to be ground. And then this is supposed to be, so the yellow one is supposed to be from the 5 volts. So yeah, you guys can't actually see, so the one here is, this is a 5 volts, and then we actually put it into the 5 volts. Is that right? Okay. Oh, there's some lights. So yeah, as you can see, our FM module with the voltage lights up. So that's a good thing. That means this FM module is working. So we got ourselves that, and then we plug in SCL and SLC. Is it SCL? I don't know why they actually call this SLC, if you guys can actually see this. It's like a small, it's very, my webcam is actually very blurry, don't know why. So SDA, as we said, this is at the one before the furthest one, and the SCL is over here. So that. Alright, now the fun part is done. We'll plug our speaker later. Yeah, we'll plug in our speaker later. And next we will plug in our... no, we will start coding actually. So I think we'll try and test out a code that we found somewhere. So first of all, I think we'll start copying the code and then we analyze. So of course I'm not going to actually like just copy someone else's code directly. I just want to know how it actually works. So hold on, let me try and get ourselves the temporarily edit sketch. Control A, Control C. So we go to our Arduino panel, Control A, and then Control V. So hold on, I think we need to we need to learn how to use this actually. So this is include TEA5767.h and wire.h. So we save this and we upload it. No such file or directory. Huh. What actually happened here? TEA5767 not installed, is it? So TEA5767. So 5767. We shouldn't actually. We should get the library as quickly as we can. Wait a second. I actually did install a library here, so it should actually work. So library TEA 57. Oh, okay. Yeah, we did install the library. So how do we not? Wait a second. Okay. Yeah, I think we didn't do that. We'll just get a library from here. I think I'll get a library online. So I'll get the library online. I don't understand why it's not working. So we will put ourselves. How do we actually put this in? So okay, wait. Okay, we put this in. So 5767. Class TEA5767 has no member name set frequency. Do you mean set frequency? Oh, on power, go to station 95.2. How about we set this to 92.9 instead? Because we don't really have it. We don't really have set 95.2. I think we actually have the we have a lot, but I don't really remember which one is it. So we compile the sketch. Did you mean debug status? What are all these errors, man? Debug status. So debug status. What else do we have? No matching function to call for TEA5767 debug status. Wow, this is going to be tough to actually use it. hold on. How about we get the library from what they give? So yeah, they didn't give us anything. There's no library. Oh my goodness, you should have told me to download the library first. Why didn't you post it on your article? Oh my goodness. So okay, wait. So before we diagnose the problem, hold on guys, let me get ourselves the I'll get myself a drink. Alright, so how am I going to need to get ourselves the library? We need to install that first. It's gonna be tough. I don't know why. I think I've already installed the library, but I don't know why it's not installing. So hold on, TA5767. Wait. Not the code. We download the whole thing as a zip. Yeah, let me get the correct library before you guys. I'll put this in my stuff. So okay. We need to import a library. Where is the where can I actually find a library? Oh, right. There we go. So if we copy, we start over and we start again, we re-upload this. So no matching function to call for TA5767 initialize? What? Do we actually have an initialize here? Wait. What in the world is this? Yeah, I can't find it. So how in the world does this work? Is this? Yeah. I think I am genuinely confused. So we diagnose the problem. Okay, the library doesn't seem to have curse you. I really want to curse the pin out SDC and SDA. Hey, no. That's not how you do that. TEA 5767. That's how you should do it. Okay, no. So we don't really need a radio dot in it. So what else? What else do we have? Do you mean set frequency? Man, this is getting tougher by the day. So do that again. No member named read status. Hell, this is not that easy, man. Okay, wait. We'll try that again. So we'll use a different code this time. Honestly, people would really like to say that coding is boring, which is genuinely not true. To be honest, coding is fun. Alright, look. Now I'm gonna show you why it's fun in just a moment. Okay, I really think that you guys can't actually see my monitor right now. So because I'm literally doing a split screen kind of stream, so you guys can't see much. So hold on, I think I will hide my camera. So I think we get the idea already that we are going to send this get an output from this baby, put this out, and we put the window capture up, and then we'll have to press the Alt button. Yeah, as you can see, it is working. So where did your radio get frequency, radio signal level? So I believe there is actually a bit something that is a bit strange. So I've already put the output, and let's check our serial monitor. They are definitely not using 9600 baud. We should be using 250,000 baud. Upload it. Okay, so what does it say when you want to actually interface this? Circuit, installing library, code. I think let's analyze our code together. The code that we have right now. So wait. If there's a, how can I actually find a website to actually upgrade this? Okay, we test the code first. We're testing the code first, but we need to find what the radio station that we need to use. Okay. Wait. There is no stations here. So what am I supposed to do then? Okay, wait. According to a certain website that I found, installing library, code. So you'll see the image in the serial output. So, oh, it's serial output, not serial monitor, but there's nothing here. Okay, let's try and upload again then. Done compiling, done uploading. Nope, serial output. 250,000 baud. Yeah, there's something wrong here. No serial plotter. No serial monitor either. Wait a second. Baud min level found. Get stations, list stations. I actually don't know this one, but frequency, radio get frequency, signal level, radio get signal level. But okay, I wonder what will happen if I actually plug my speaker. So hold on a second. Let me get the speaker. So here is forgot to turn on the bloody camera. So okay, if we want to get that, okay. So here's the speaker. This is the speaker. Here is the other half of the speaker. So we're gonna have two speakers. So these two speakers, they're going to be used to produce the output, I think. So let's just plug this in. So do that, and nothing comes out. Is this the correct plug? I I think if you can see, this is the green. It has some green lines. Oh right, I forgot to turn on my plug. So because this is a USB powered device. So let's try. Okay, if you can hear some static noise, then you can actually, yeah, there it is. So hold on, I think we'll find the frequency of this, because it just needs to get some extra. Okay, this doesn't seem to be the code that I should be finding. Or what if we just raise the level of the speakers a bit? No, nothing is coming up. So we need to get another article. I think I'll find another article. What time is it now? 9:47. So we have a lot more time to do. So wait. The 5767. Go back to the article that doesn't have the library installed. Why do you have to put it in A4 and A5? Arduino pins A5 and A4. Okay, so if they say that that's the pin for Arduino SDA and SCL, is it? So we'll do this. Oh, oops, wrong. Reset that. No, put this out. Put this in. So pins. So this is the analog pins. You will receive data that is analog. So A0, A1, A2, A3, A4, A5. Plug that in. There we go. And it's super damn tight. Just shove it in there. And okay. So once we stuff it, we shove that in, we get ourselves the code that we need. Hold on a second, let me get the code first, and we put this in, okay, so we'll change the radio to 92.9. If any of you Malaysians know what 92.9 is, that is the radio for hits.fm. That's kind of one of my favorite radio stations, but it's kind of bad now actually. So okay, so we already have our first error. We have an error again. Wait, let me try and get them. Yeah, I think that, yeah, this is definitely an error because we are literally interchanging the radio module, interchanging the TA5767. So okay, let's try and use this one instead. No radio function for call to matching to init initialization. Literally set frequency. Come on, give it a caps lock, man. Class T5767 has no number named radio read status. Yeah, I think I need to learn this off stream, or maybe I should just go somewhere else actually. But yeah, I think this is not this doesn't seem like a good code to actually use. also FM radio Arduino. So hey, wait. Huh. Yeah, I think we've stumped to our really bad problem here. We are starting to stump. So let me get ourselves a bunch of code to use. Okay, I found this radio to use. So okay, so I've found another one, but I don't think you guys can actually see it. Because this guy puts his T module. Oh wait, this guy uses an Arduino Nano. Yeah. That's why I can't really see the SDASEL. Alright. So we're just going to use that. We're just going to use this. Let's see if it. Oh wait, the port. I'm going to change the port. Okay, so I believe we. Oh, hello you. Welcome to the stream. So as you can probably see, we are stumped and we can't find our solutions. So I think I don't really know what I am trying to find here. So okay, so I think it's time to make sure if I need to understand what I need to read. But before that, my throat is getting painful, so let me just go and get myself some water. Alright, and I'm back. So I actually think that I might need to find a way to get through this first. So maybe the stream will be a bit low on quality because it will be quite the quiet stream. So hold on to your boots. So let me just find myself a little something. Wait. I mean, I think we should add a bit more components because the coding part might take a while to submerge into. So let's open that. Okay, my earphones are all over the place. So let's get ourselves the. Whoa! Shit! Something's wrong. Something's crackling. So this is the Arduino board. Let me get myself potentiometer. So we use this potentiometer to actually, wait, I'll show it here then. So this is used, I think we'll use this to adjust the frequency that we want. So just to make things easier for ourselves. So if I remember correctly, oh wait, yeah, you can see it over here, which you can't see, unfortunately. I apologize for that. That is a 10 kilo ohm potentiometer. So this will be used to adjust the frequency that we want and to ensure. Oh my goodness. Sheesh. I dropped it. I dropped this poor baby. Oh dear. Is there any bent pins? I don't think there are any bent pins, so I think all is fine. So all is fine. So we put the potentiometer, we'll just put it in a random place because just so that we know where it is. Okay, speaking of which, there are 3 terminals in this pot, I think. Yeah, there are 3 terminals. So the middle one is the compulsory port that you have to connect because you need to know which the resistance, because that is going to be the one that is going to adjust to determine how much resistance goes into your system. And you can choose either one of these terminals to actually be put into your, to connect it to your system. So put this. Yeah, that's not even a final product, is it? So hold on, let me find some other component. Yeah, let me find some other components. So let's switch this off. Okay. That is a lot of items, big numbers, tiny font. So set mono reception, set stereo noise cancelling on, init scratch screen, so splash screen serial begin, analog read, analog pin. Analog pin is 0. So analog pin is 0. Wait, is that actually possible? Analog pin is supposed to be A0. So where is this coming from? Whoa, shit. Oh, they literally call it AO and A1. Oh, I see. So let's all place the parts on the breadboard. We connect every ground pin to the power breadboard's ground rail, and the VCC pin to every part of the breadboard's positive rail except the potentiometer, which will control the volume. Collect the radio module. Okay, no, not the audio signal. Wait. How do you adjust this FM radio? Hold on. Yeah, I don't understand a single thing on what they're actually doing. Yeah. So, okay. Forward button is pressed, backward button is pressed, go up to the next station. So void setup, radio set mono reception, radio set stereo noise cancelling on in its screen, show splash screen, serial begin, blah blah blah, II50 value plus analog read analog pin. So this guy send it to pin 0 on its Arduino Nano. I think I need to find some more stuff. Okay, how can we find that actually? You only need to connect 8 wires. The brains of the projects are the small and inexpensive Arduino Nano. Okay, so we need to find a way to get the frequency of the Arduino frequency. Yeah. Initialize the radio model and display, and we display a splash screen for 3 seconds. Design a splash screen in Photoshop. Watch the video tutorial. Next, in the loop function, achieve a stable frequency. So frequency integer would be the map. Yikes. That's a little bit tough. So yeah, the electronics part, the hardware part, I already got it. So now we're going to see the software part. Hold it. On power, go to station 95.2. Accept only this and that from the keyboard. Radio read status. Buffer is 10,000 plus 0.5 over 10. Stereo, radio, stereo, buff, signal level, radio signal level. When button press, search for new station if search mode is equals to 1. Serial available greater than 0. Radio status buff is equals to 1. Flag equal to 0. If else, if stereo, serial print stereo, serial print mono. If forward button is pressed, go up to the next station. If backward button is pressed, go down to the next station. Ha! The message will be printed only once. You might need to understand the commands that are used by this TEA. So let's see. Yeah, there's a lot of codes to use this, so I definitely need to revise this a bit more off stream. But I think there's an easy way to actually interface this. So TEA 5767 FM radio module. Let's try and search for YouTube. We just do a simple interfacing so that we don't really need to use we don't really need to use the hard codes like that. So yeah, I think I need to find the interface. Which is not easy to actually find this. Yeah, I actually found it somewhere, but oh, there you are. Okay, so what we did, alright, I think we'll have to delete everything from here. Because we need to interface this. So wire.begin. Oh, TEA 5767 dot radio. Okay. This is the module, which is the TA5767 radio. Wait, we'll delete this and we'll do the simple void setup. Keep in mind that Arduino is usually done in C++, so void setup void loop. So I think we have to include a few libraries, which is just the same as C++. We need to include the standard library usually, but this is Arduino include TE5767.h include.wire.h. Forgot to add a space there. Wire.begin, and also radio. Wait. We need an object of radio. I forgot to do that. So TA5767 equals to FM radio, which is equals to TA5767 include live, which is the library, wire.begin. FM radio is equals to FM radio dot get frequency 92.90. So we'll get ourselves the hits FM and we'll check whether or not this is actually working. No function for call to 5767. Okay, I don't know which one is the maximum level. Okay, this is the minimum. Okay, I found the minimum. So FM radio, get frequency. Huh. Where can I find this? Yeah, we need to set the frequency. It should be set frequency, no? Yeah. Okay. So we've uploaded the code, and now okay, something's wrong with my speaker. Okay, we check this, see if it's working or not. I mean, this is just a simple interface that I'm going to do, that I usually do. So here's the speaker that we have, and we blast it up a bit. Okay. Yeah, nothing's coming out. So yeah, nothing is actually coming out. So is it because of the cables? Yeah, something actually happened. Something wrong happened. Okay, we plug it in. FM radio, set frequency 92.9. This thing should be okay already. So pick your own frequency. Or do we have to actually put it to 92.9, not 92.90? Don't understand why. So okay, we've set that. And no, nothing is coming out. Yeah, I can hear some static when I'm actually plugging this in, you know, so look at that. There. So now you see it's plugged in. So once it's plugged in, we should be raising the volume a bit, or we increase the length of this antenna. Yeah, make it a bit longer. But it's not. So yeah, I've made the antenna much longer this time. So if you can see, there we go. Yeah, this should have worked, but it's not actually working. That's gonna be a problem. So I think we will stop. Yeah, we'll definitely stop the stuff. Okay, I think I'll analyze the previous code that I actually got just now. Yeah, I apologize if I actually forgot to show this to you. So okay, so the frequency integer is a map function. So value plus analog read analog pin, which is to 0. So oops, sorry about that. The analog pin A2, A1, A0, 1, 2, 3, 4. Alright, I think we're getting there actually. Okay, so let's analyze this code first. I think we'll show it to you guys. We'll do a window capture. Let's use this and close it. So close this video capture device. So radio set mono reception, set stereo noise cancelling on, initialize the screen, show the splash screen, and then serial beacon 9600. Okay, we read the analog pin, and we read the delay, we read the values. So we got the float, and then the frequency, previous frequency, LCD clear screen, radio select frequency. Oh, okay. I get it. So float frequency equals to frequency integer over 100.0f. Okay, that means it's a 1 decimal place. I think it is 1 decimal place because we just want to keep the floating points over here. So okay, radio select frequency, print signal strength, print stereo, print frequency. There's a function that says print frequency, print stereo, print signal strength. We don't really need that, so void loop. Print frequency is the one that we're going to put on the OLED display. We're going to do the FM radio soon, so okay, these are the other ones. I see. So the ones that we don't need is actually print if frequency, previous frequency, or previous frequency greater. Where is the previous frequency? Frequency 0, signal strength 0. Initialize the screen. So what is the map function? What in the world is this? So map function in Arduino. So in Arduino, as previously mentioned, the map function uses integer math. Remaps a number from one range to another. A value from low would get mapped to low, 87 to 10107. What's the range for Malaysia radio stations? I am opening too many Google tabs, so I think I need to throw this out for a bit. Hold on. I think I need to remove all of these. Remaps a number from one range to another. That is, a value from low would get mapped to low, a value from high to too high, values in between to values in between. So what is this? The value from high to low to high. So if we want, so the value is 13 actually. Why is the value from 2 to 1014? Is that the analog value? Wait, let me see. So analog value in Arduino 1014. But why is it from 2 to 1014 if the analog read is actually from 2 to 1014? Why is it like that? So the value, we'll divide it by 30, in which case I really don't understand. Okay, the code works like this. If first we initialize the radio module and the display, and we display a splash screen for 3 seconds. Design a splash screen in Photoshop. Watch the video tutorial if I have attached. You want to know how to update your graphics to a Nokia 5110 display. Next, in the loop function, we read the value from the potentiometer that controls the frequency every few milliseconds. We get the analog value from the potentiometer and we map it to a frequency value. Analog value, we map it to a frequency value. So 2 to 1014, 87. Since we write an analog value, this value is not constant. It goes up and down slightly even if we do not turn on the potentiometer. So to achieve a stable frequency, we only tune the radio to a different frequency if the frequency has changed considerably. So if there's a significant shift in the frequency, we turn the radio module into that frequency, we get the signal strength. We only tune a radio to a different frequency if the frequency has changed considerably. If there is a significant shift in the frequency, we tune the radio module to that frequency. So the mapping is analog value from the pipe, and we map it to a frequency value. Oh, we do some mapping from low from high. The lower bound of the value's current range, the upper bound of the value's current range. So we need to check the maximum value of this guy's potentiometer. So if this guy's potentiometer is a 10K potentiometer, so from what it says, it's from 2 to 1013. So a potentiometer, okay, there is no values that we can actually see, but let's just follow his orders for now. Okay, analog value Arduino, let's stick out the Malaysia radio station. So our range is from 87.7 to 107.5. So that means we need to do from 87 to 108. Oh, wait a second. So float frequency will get the integer frequency. So that means if we map the analog, so okay, now I understand what this actually means. So from the 0, not from the 0, the 2, the 2 represents the maximum value of 8700. So when the value, so when it starts, when the potentiometer, let's turn on the camera. Hold on, let me check this out a bit. Okay, my mouse is actually onto the Arduino screen. Let's go back. So there we go. So let's say this potentiometer to the left. So this is from what I actually understood from the mapping function. I actually just closed that window. Oh my god, things are getting a bit confusing. So okay, FM radio receiver, that's not the FM radio receiver, that's wrong. So okay, there's a lot more FM radio receiver, but I'm not going to actually use that because we're just going to make things simple for this project. So okay, so let's get it on this time. And wow, I am getting so tired actually from all the streaming. So value 2, 1014, 8700, 10700. So okay, let's say this potentiometer, the minimum value is 2. So that's going to be the least value that this potentiometer has. So if we increase it to the maximum, this would be 1014, 1014. So that's going to be the maximum value. So what I'm trying to say is, at this minimum, if we assume that map function is basically this potentiometer, so the 2, which is the minimum value here, represents 8,700. And then if we turn it to the maximum value, so this is going to be the maximum value already, which is from the analog is actually 1014. That 1014 inside this analog actually represents 10,700. So if we look back from our code, it says float frequency equals to frequency integer 100.0f. So that means it's going to actually divide our values, our representing values, like let's say the 8,700. So that 8,700 will actually change to, since we're dividing it by 100, it would be 87. So 87.0 megahertz, which is going to be a frequency. This is going to be a frequency that we're going to actually use. So there's no 87.0 in Malaysia. There's only an 87.7, which is Radio Classic, RTM, and a Malay language. So this is for the oldies. Otai masih berpisah. So okay, that's gonna be 87.7. So 8770 to 107.5. So wait, let's see. So this is not going to be the code that I'm going to use. So this is going to be 8750. I forgot which one was it again. 8770. So this one is 10750. So that's going to be the maximum values, and then after we get the maximum values, we divide this by 100. So once we divide this by 100, we will basically get the radio frequency. So where's the previous frequency? So if the frequency minus the frequency, okay, this is just according to my understanding. Since we're inside this loop function, we're going to actually this is like a main function for all of you C++ developers out there. The if you know int main, this is basically the function that will put everything inside there, and that's going to be the starting point of your program. So this is void loop. So void loop, if the so this thing will actually loop. So if frequency minus previous frequency, which previous frequency means 0 up here. So if it's greater or equals to 0.1 floating point, or if the previous frequency itself minus the frequency is greater than or equals to 0.1 floating point, we will do all of this, which is basically printing the output of the radio. So okay, this signal strength is signal strength and stereo is not really related to our what we're going to learn for tonight. So we're just only and also the LCD clear screen actually, and also the print frequency, because these things are more related to the OLED display. If it's inside this code, it's actually going to be a different screen, but we're going to focus on the OLED sensor, OLED screen. No, OLED display, which is going to be focused tomorrow night. So we're just going to focus on this class and also the function select frequency. but there's a lot of TEA5767 libraries, so it's going to be different. I think in our case, the ones that we used inside. Wait, let me check. Let me check this. So in our case, what we're actually going to use is the set frequency, not select frequency. So that's going to be the frequency that we'll actually be using. So we'll go back to this code. Okay, so that would mean that's about it then. And then we set the values back to 0. Okay, what I don't know is what does this val actually mean. So let's go back to the article and read. What is that for actually? I don't understand. So once we got the code, val equals to 30. Why do we have to do this, and we have to divide it by 30? So for I 30 and a 30th, why do we actually have to put a 30 in there? So okay, what is this val? I don't understand. Nokia 5110 330 picofarad capacitor to a breadboard like this to reduce the noise on the audio signal. So okay, wait. I don't get this. Okay, so this is the setup. The stereo noise cancelling on, frequency integer, float frequency. This is pretty strange. Oh shit. Sorry about that. You guys can't see the camera, but still. So watch the video tutorial I have attached if you want to know how to update graphics to a Nokia 5110 display. The code. So in the loop function, we read the value from potentiometer that controls the frequency every few milliseconds. Oh, we read it. So first of all, I think int val from what we see here is 0. Yeah, initially it's 0, so plus the analog read pin, and then we divide this by 30. So if the value, hold on. The map function. Wait. So I need to understand the mapping function. Does not constrain values to within the range because the out of range values are sometimes intended and useful. The constraint function may be used either before or after this function if limits to the range are desired. Lower bounds of the range might be smaller, larger, or smaller than the upper bounds, so that the map function can be used to reverse the range of numbers. 15051. Oh, so basically what we got here is we want to summarize it, or no, I don't think it's going to summarize it, but we're going to, so let's say if our potentiometer, let's get ourselves the let's open up my webcam again. So we open up our webcam, get ourselves the pot. So let's say if you set this to like a certain value inside the pot. So inside the pot, we have to calculate we have to calculate the analog read plus the value divided by 30. So and then we set the value from the aforementioned frequencies earlier, which is 8770 and 10750. So okay, value plus analog read equals to analog pin. So that means it's just going to constantly, so that means before we actually change anything, let's just say, because you need to know that computers actually work at the speed of light, so it's going to actually run this code, this one file of code, in like maybe milliseconds. No, not milliseconds. Maybe even faster than that, in the form maybe in nanoseconds, I think. So basically, if you set this value, like for example half, let's just assume this value is maybe 512. So 512, and then from the, if we switch this, hide this, if you see that this analog read analog pin, so to what our potentiometer has been set just now, we add up together. We add up until the I reaches 30 with a 1 millisecond delay. Yeah, so from what we got, so what we got here from this, if that we increase, we could actually map the values in between two. From, if we map the val, which is in between 2 to 1014, it can be either 8770 or 10750, and then we divide the frequency. So I think that's how my understanding of this code actually works. It's very simple, but not really that accurate actually, so we need to find another way to use this. So okay, how about maybe if we test the potentiometer, how much are the analog values? Maybe that could actually do the trick. So okay, I think what I remember now, what I know now, is this is going to be the function that is going to adjust all of our frequencies, and then when we start going to the if statement, so this if statement, this is going to be the one that is going to print all of our outputs, so LCD, clear screen, signal strength, stereo, and frequency. So okay, so I think we've got it done now. So I think we'll continue. What time is it now? 10:40. So I think we'll continue this into our FM radio video. So that one is going to be the one that is going to use, that will be the one that will finalize this project. So I think we'll go over to what we have learned. I think what me and you actually have learned. So we got ourselves the video capture device. I think we can take this off already, the Arduino. So okay. Okay, we'll take off all the cables this time. Now we get that. So the first thing that we've learned is this baby right here, the heart of our FM radio. So this is going to be what we're going, this is the TA5767 module. It has 4 pins, 2 jacks, one for FM and the other for speaker. So, and then we have the pins at the bottom, which is the 5-volt, I'll have to read this for you guys. So SDA, SLC, and also ground. So the SDA and the SLC pins are connected to the Arduino board. Again, a friendly reminder to use the Arduino Nano board. I just took it out just to see what pins we're using, because again, I can't use this anymore. I can't use this actually. So A0 is the digital pin. So this is just going to be the brain that is going to perform all of the functions. Basically, it's like the CPU on the laptop, and it's going to actually use this to run the code. The chip inside here is actually the Atmel Mega 328P, if I remember correctly. Same goes to this Arduino board. It also has this, which is basically the same thing, but somehow this is much smaller than this one. See, I placed them side to side. This should be the microcontroller chip. Yeah, this is much smaller than I thought. So I think the Arduino Mega, there's the Arduino Mega, but Arduino Mega is much better than these two babies. So okay, you connect this. If you want to use this, it's definitely recommended to use the Arduino Nano. So I'll just use the Arduino Uno. So A4, if you remember, A4 pin, A5 pin is actually the pin for the SDA and SCL. So I think A5 is the SCL, A4 is the SDA. We've also learned about the potentiometer. The middle one is the compulsory pin that you're going to place inside so that you can actually adjust the resistance. And here's the other two things. So we're going to use this to put this on the circuit so that we send a voltage to it, and we'll use this knob right here to adjust the resistance. And I think that's about it. I think for the code, we've learned how to actually adjust this thing. I've already plugged out. I removed my Arduino and unplugged it, so I can bring in my mouse back. So we close this, and then we put this. This is the code that we're going to use as the one that is adjusting the frequency of this module. And also, yeah, I think that's about it. I apologize if I can't actually give you guys a working product. I'll try my best to make a video out of this, and make sure you guys stay tuned for that. So okay, I'm going to end the stream. Kon-Kazu everyone, thank you for coming to my stream tonight. I hope you guys learned a lot with me. So, and I hope that we'll see you all. I will see you all tomorrow for the next stream. So if you like the content that I make, please leave a like, share it with your friends and family, and subscribe to my channel. So thank you guys for watching. Kon-Kazu, and bye bye.